Hi students, warm welcome to all of you. It's very nice to hear you are well going on studies. Keep up the good work. Today I am going to teach you 11th chemistry, the first unit, and our today topic is empirical formula and molecular formula. What is empirical formula? The empirical formula means it is the simplest whole number ratio of atoms of each element in the compound. If the compound having many number of elements and many number of atoms means we need to write the simplest formula for the compounds. The simplest formula is a molecular formula. You already know that. But the empirical formula is very simplest formula than the molecular formula. For example, C6H12O6. It is the molecular formula for glucose, but the empirical formula is very simplest formula, the ratio of this compound. Empirical formula is written by the ratio. The carbon present in this is a 1% ratio and hydrogen is in 2 ratio and oxygen is in same 1 ratio. So, the hydrogen is in 1 ratio. So, the ratio is 1:2:1. So, this is the simplest ratio. By the simplest ratio, if you write the compound name means it is the empirical formula. So, the compound is CH2O. It is the very simplest ratio of the glucose molecules. So, this simplest ratio is the empirical formula. So, what is molecular formula? See here, the actual number of elements present in the compound is the molecular formula. So, in the molecular formula, we need to write the perfect, accurate, the actual number of elements present in the molecule. For example, the glucose molecule C6H12O6 is a molecular formula. So, each glucose molecule contains 6 number of carbons and 12 number of hydrogens and 6 numbers of oxygens. So, molecular formula is the accurate or the actual number of the elements present in the molecule, and it is a whole number of multiple of the empirical formula. From the empirical formula we can find the molecular formula, because empirical formula is the simplest ratio, and if the ratio is satisfied into actual number, that is the molecular formula. Okay. So, let us see the difference between the empirical formula and the molecular formula. Empirical formula has lowest whole number ratio and the molecular formula have true number of atoms of each elements present in this. And for example, CCH6 is the molecular formula for benzene, and its empirical formula has simplest ratio 1:1. So, it can be written as CH. It is the empirical formula. Okay students, so you know well about the difference between the empirical formula and molecular formula. Now see, I show you an example to find the molecular formula of compound from the empirical formula. For example, a compound have the molecular formula. You need to find the molecular formula. First I give the empirical formula CH3, and its mass for molar mass is, molar mass of this compound is 15 gram. So, can you find the molecular formula for this compound? It is easy to find. I show you. First you need to know the molar mass of this compound. This compound has a molar mass. We can find it by multiplying the mass by the number of atoms present in this. The carbon has the mass 12 and number of atoms of carbon present in this is 1. So, total number of mass in carbon is 12, and we have 3 numbers of hydrogen also. So, the weight of hydrogen is 1 and 3 number of hydrogen can have total mass 3. So, same 15 gram of CH3 present in 1 mole of CH3 molecule. So, the molecular mass or molar mass of CH3 is 15 gram. The given mass also a 15 gram. So, we can find the value n. N is the ratio between given mass and the molar mass. Given mass is 15 and the molar mass also is 15. So, the n ratio is 1. From the n we can find the empirical formula and we can find the molecular formula from the empirical formula. The empirical formula is how many times we get the number of n, that n is multiplied the empirical formula to form the molecular formula. For example, here if we get n have 2 means the empirical formula twice times produced to form a molecular formula. Now, we have only 1 as n. So, the empirical formula is multiplied by only the number 1. So, we have empirical formula CH3, we have 1 times. So, we can have CH3 as a molecular formula. It will be a ionic form. So, because CH4 is a full form of this compound. For example, another compound I will show you. Let us see here. I make small change in this compound. If you take 30 gram of CH3 as a given mass, the given mass, if it is 30 gram means the molar mass of the CH3 is 15 gram. So, the given mass when divided by molar mass, we can get 30 divided by 15. So, the answer will be 30 divided by 15. So, we get the number 2. So, the number of empirical formula twice number we get 2. So, Em can have 2 in the base. So, 2 times empirical formula is a molecular formula. CH3 when written as 2 times, we can get CH3 and another CH3. So, it is the compound of ethane. CH3 and CH3 is the compound of ethane. So, 30 gram of given mass and CH3 as an empirical formula, this sum will give the answer ethane as the final molecular formula. So, from the empirical formula we can find the molecular formula. Before that we need to find the molar mass of the compound. So, this is one example for sum and see the next. It is another example. We need to find the empirical formula. First they give the element and the percentage present in the element. If the substance containing elements in a particular percentage, we can find the empirical formula. See the sum. An acid found in tamarines on analysis shows the following percentage of composition. Acid contains the elements that contains the percentage as 32% of carbon and 4% of hydrogen, 64% of oxygen. Find the empirical formula of the compound. We need to find the empirical formula. Do you know how it is? ISO. See this. We have the elements carbon, hydrogen and oxygen. The percentage also given as 32, 4 and 64. For carbon 32, for hydrogen 4, for oxygen 64. We already know the mass, molar mass of a particular element. Carbon has the molar mass 12 and hydrogen has 1 and oxygen molar mass is 16. We know the value, no? From this we can find first the relative number of moles present in the substance. The moles can be calculated by the division. See this, 32% we divide by 12, we can get 122.6. So, the relative number of moles present in this compound is 2.6. For hydrogen 4 divided by 1 is equal to 4, and for oxygen 64 divided by 16 is equal to 4. So, we can find relative number of moles from the molar mass and its percentage. Relative number of moles can give the ratio, simplest ratio of the elements. The whole elements combine to form a molecule. In the molecules, each element gives a simplest ratio. The simplest ratio we want to calculate by dividing a minimum lowest number, in which the number of moles have we 2.6, in which the lowest minimum number is 2.6. We need to divide the 2.6 for all the numbers. When 2.6 divided by 2.6, we can get answer 1. 4 divided by 2.6, we can get 1.5. Same answer we will obtain the third one. So, this is the simplest ratio, but it is not in a whole number. It is in a point number and decimal values. To form a whole number, we multiply this by 2. We can get 2 and 3 and 3. So, this is the ratio of the elements. From the composition elements, we find the ratio of the elements. From the ratio of the elements, we find the molecular formula by like this: carbon, hydrogen and oxygen has the ratio 2:3:3. So, C2H3O3. It is the empirical formula for this compound. From the percentage and the molecular mass of the compound, we can find the empirical formula of the compound. It is one of the sum present in that your textbook, and you also write another sum. Evaluate yourself, that is a compound on analysis gave the following percentage of composition. Carbon have 54.55 percentage and hydrogen has 9.09 percentage and oxygen has 36.36 percentage. Determine the empirical formula for the compound. Students, you write the answer for this sum and send us a photography for corrections. And our next model is determining the molecular formula from the empirical formula. At first I write the sum, that is CH3 in 15 gram percentage and CH3 in 30 gram percentage. That sum also can have the same model. From the empirical formula, we find the molecular formula. In the model, we have 3 steps. I show the steps. Before that, see the sum. The empirical formula for a compound is P2O5. Its experimental molar mass is 284 gram per mole. Determine the molecular formula of the compound. So, P2O5 is a empirical formula. That means 2:5 ratio. The compound can have 2:5 ratio, 2 ratio of phosphorus and 5 percentage of oxygen. So, the P2O5 is the empirical formula of the compound. To find the molecular formula of the compound, the empirical formula, how many times want to multiply it, that only need to be find, that how many times is the number n, small n. So, we need to find small n first. So, from the empirical formula, if we find small n, when we multiply the small n by empirical formula, we can get a molecular formula. To form this, we need to find 3 steps. The first one is step 1, find the molar mass of the empirical formula. At first, we have the empirical formula of compound P2O5. We need to find the molar mass. So, P2O5 contains 2 numbers of phosphorus and 5 numbers of oxygens. 2 numbers of phosphorus can have the value 61.94 gram per mole and 5 numbers of oxygen can have 80 gram per mole as the molar mass. So, the total molar mass will be 141.94 gram per mole is the total molar mass for P2O5. So, first step is to find the molar mass of the empirical formula compound. And our next step, step 2, the molar mass of the compound is divided by molar mass of empirical formula. To find the value of n, we need to divide the molar mass of the compound by empirical formula mass compound. The molar mass of the compound is given in the sum 284 gram per mole, and the empirical formula of the sum is 141.94 gram. When we dividing this, we can get the n value 2. So, number 2 is the multiply number of empirical formula, that value is n. So, n is equal to 2. When n is multiplied by the empirical formula, we can get the molecular formula. That is our step 3. Step 3, multiply subscripts from empirical formula by answer from the step 2. So, step 2 answer n is 2. When 2 is multiplied with P2O5, 2 P2s are P4 and 2 O5 are O10. So, P4 O10 is the molecular formula of the compound. This is the answer. So, from the empirical formula we can find the molecular formula, but before that we need to know the molar mass of the compound. So, you know about the second model, and I give you another sum as your homework. A compound X has 92.25 percentage carbon and 7.75 percentage hydrogen. If the molecular mass of the compound is 52 AMU, we need to have a molecular mass. From molecular mass only we can find the molecular formula. So, calculate the molecular formula of the compound. So, the empirical formula of this compound is not given. You have a molecular formula and empirical formula is not given, you know. Then how do you find the answer? You have only the percentage. You need to find molecular formula. To find the molecular formula, you need to have the number n and the empirical formula. We can easily find the number n when we have empirical formula and the molar mass. When we have empirical formula and molar mass, we can find the number n. But we do not have empirical formula in the questions. How can you find the empirical formula? To find this, we need to have the percentage of the elements. From the percentage of element, we can find the empirical formula, and we already have the molar mass in the sum, and we can find easily the number n. So, the molecular formula is calculated easily. So, it is your homework, you need to find it answer. Okay, students, the study materials and question bank are given in the description. See the below description, and your self evaluation question paper also given. You need to write the self evaluation test and send us a photography for corrections. Dear parents, please make sure whether your students complete the self evaluation test. Thanks for making time to watching this video. Thank you.
Nalini Amurtha's father. KGலேருந்து 8th ஸ்டாண்டர்ட் படிக்கிறாங்க. இப்போ காலையில் 5:30 to 6:30 வந்து கிரவுண்ட் ரன்னிங் ப்ராக்டிஸ் பண்ணிவிட்டு பாடி எக்ஸசைஸ் பண்ணிவிட்டு அப்படியே ஸ்கூல் அட்டன் பண்ணிவிட்டு மத்தியானம் மேலே மதர் தெரேசா அகாடமிலையும் ப்ராக்டிஸ் பண்ணுறாங்க. மெட்ராஸ் எம்இஎம்லும் ப்ராக்டிஸ் பண்ணுறாங்க. நேஷனல் லெவலில் வந்து கோல்டு அடிச்சிருக்காங்க.
நான் அரக்கோணம் மாவட்டத்தில் 6 வருஷமாக டேபிள் டென்னிஸ் கோச் இருக்கேன். ஸ்டடீஸ்லேயும் சரி, ஸ்போர்ட்ஸ்லேயும் சரி, மாவட்டத்தில் அப்படியே வந்து ப்ராக்டிஸ் பண்ணுறதுக்கும் அதே நேரத்தில் ஸ்டடீஸுக்கும் வந்து அவங்க எந்த ஒரு பிரச்சனையும் இல்லாமல் 2 விஷயத்தையும் அழகாக